Hey guys, it's Miss Talent. So we're going to go over our notes today over the light unit, but I'm going to go ahead. You should be able to see my screen right now. I'm on Canvas, and I'm going to kind of show you where to find things. A lot of the questions I'm getting is kind of like what to do, when, and where to find it. So I'm going to kind of go over that. If you are doing hard copy, everything should be in the same order as well, so it should not be very confusing. But this is what your Canvas will look like. You are already done with week 1 through week 4. I am still waiting a lot of assignments from those 2 weeks, and you can still submit as you go. If you're having problems submitting, please send it through a Canvas message to me. It does not have to be perfectly submitted. If you're, a lot of you are saying you're getting an error message, and so just go ahead and send it through either a Canvas message, or a lot of you all are sending photos through Remind of your hard copy unit packet, and that is totally fine as well. So just keep in mind, even though I might not be getting it in the submission box, you can still submit it those two other ways. So here is the weekly agenda for the next 2 weeks. So when you click on it, it breaks it down for you. So this is week 5, and I went ahead and put the dates so it's not confusing. You're going to handwrite your notes, which we're about to go over, and then you're going to complete your entire unit packet, and then you'll submit it. Next week, though, you will pick only one of the following. Either do the light gizmo and submit, or you can pick one or two of the do-it-yourself at home labs, and you can just send in a picture of what you did through your lab. So either one is fine, but you'll pick one. You don't have to do both. You're welcome to do both, but you do not have to do both. So you will only have one assignment each week that's physically graded and due. So this week, week 5, is the unit packet. Next week, you get to pick between either the gizmo or the lab. So like I said, just look at those. This is all one submission box, and this is one submission box. So I'll be looking for both of them. So I hope that kind of clears up. When you go back to the module, you will see there's your light packet. Here's your Quizlet for your vocabulary, your notes that we're about to go over, your textbook, and then here is where you'll pick between the gizmo or your do-it-yourself projects, and you'll submit in the same spot. So it doesn't matter which one you pick, you'll still submit in the same box. So I hope that kind of clears up a little confusion. I know Miss Henson and Coach V's Canvas looks exactly like mine. We made the modules together, so it should not be confusing. So like I said, I just wanted to kind of go over those few things that I had noticed the past few weeks that were confusing for some. All right, so let's look at our notes. So you could, I'm not going to give you time to write them just like we've been doing, but you have a hard copy of them or you have them on Canvas. But I am going to go over them so you feel good about it. So we're going to go over light, and I wish we could be together for this unit. It is a cool unit. And light is just really interesting the way it works. But your do-it-yourself labs are really cool. That we have collected for you all to try out to go over these things. So since we can't be together, we definitely can have that. So 12.1 is how light travels. So light source is an object that emits its own light. So it produces light. Okay, so it is not something like a chair. A chair does not produce light, but a lamp, a light bulb produces light. So flame, sun, light bulb, the computer screen, those are all examples of a light source. Light rays, like the sun, light travels in a straight line. So light cannot bend around a corner by itself. So it is always going to travel in straight rays. So I want you to think of, like, when you draw a sun, you're drawing straight lines out, or the little triangles that make to a point, because that's how light travels. They're in straight lines. We can classify things as luminous or non-luminous. So a luminous object is something that produces light. Once again, a lamp, a computer screen, a sun, things like that. Those are luminous objects. Non-luminous, they do not produce light. So we see them because of the reflection of light. So at night, when we didn't have power with the windstorm, you were able to see your chairs and things because you were using candles. If we had not had the candles or, say, a gas lamp or something like that, you would not have been able to see the chair because it is not luminous. Same with the plant, a couch, a bed, those things. 12.2, how shadows are formed. So first, let's go over 3 words that are kind of confusing from your vocabulary. Transparent. We know what transparent is, but it's kind of hard to explain. It shows where light can pass straight through it. So it is kind of like a semi-clear object. So, for example, a window is transparent. Opaque, or I always mispronounce that one. Y'all know me. Light is being absorbed by the object, and it may gain warmth. So it's being absorbed, but is not being reflected or going through the object. Okay, reflection is light bouncing off of an object like a mirror or things like that. Or like I know y'all all love those cool sunglasses nowadays with all the cool different colored shades. Those are reflecting the light. Now let's talk about shadows and shade. Light from the light source is blocked by an opaque object, creating a shadow. That means light cannot go through it, okay? But light can't bend either through the corners, so it travels in a straight line. So, of course, with my diagrams, here's a tree, okay? Here's the sun rays coming down. So the sun rays go down, but then do they go through the tree? No. So this would be the area of the shadow. So that is why shadows exist, is because light will only travel in a straight line and things are in the way, and then it causes it to create the shadow. And there's a really cool 2 or 3 do-it-yourselves with shadows. So I want you to labs. So I want you to make sure you look at those. 12.3, reflections. So paper does not allow light to bounce off very easily. So here's this beautiful light rays coming in, and then they get like just all jumbled up because the paper, even though it looks smooth to us, if you really put it under a microscope, paper is a really rough surface. But a mirror is smooth. So look at this. Every angle that it's coming in, it is bouncing off perfectly back out. And the way I made these, just so you know, is with a protractor. And if we were in class, you would have gotten a protractor and I would have showed you a few tricks to that. But there's a way to show, say this was 45 degrees coming in, it's 45 degrees going out if it's a mirror. Predicting the path of light. So there's actually a law that states that the 2 angles marked in the diagram are equal. So the incident light ray is going to be the same as the reflected ray. And the angle of incident is going to be the same as the angle of reflection. So let's pretend that the angle of incident is 45 degrees. Okay? So it's 45 degrees coming in. Okay? It's coming in. And then it's going to bounce off another 45 degrees. Normal will always be, here's the mirror, and normal is always going to be 9 degrees out perfectly, okay? You all know this from math, so this would be like a square to this line. Just like a 90-degree triangle you would have right here, okay? But just like I said, the incident ray is always going to equal the reflected ray. So you're going to have the angle of incident might be, say, 20 degrees. Then the angle of reflection is 20 degrees. If the angle of incidence is 65 degrees, the angle of reflection is 65 degrees. It's not going to change. Please make sure you write this part down. It is so simple if you remember it that way. Now, if we were in class, I would give you protractors and I wouldn't have told you all this, and I would have made you actually measure them all, and then you'd been like, oh, they all equal it together, but you remember it. So please make sure you write it right like this, because that is the easiest way to remember it. Angle of incident equals the angle of reflection. All right, 12.4, how does light bend? So the only way to get light to bend is using another object, okay? Something has to create it to bend. Remember, light travels in a straight line. So refraction is the change of direction of a light ray when it enters and leaves a transparent material. That material is what's causing it to bend. If that material wasn't there, light would travel in a straight line. So a light ray bends towards the normal when it passes from air into a transparent material, and the light ray bends away from normal when it passes through a transparent material into the air. You do need to write both of these. I know they seem like the same sentence, but they're the complete opposite. So make sure, and then you need to draw your picture. So I'm going to show you. Here is a glass of water with a coin in the bottom. Here's your eye looking into the glass. Okay? Your eye is looking into the glass, and then it's bending towards normal. Remember, the dotted line is normal. Okay? So it's bending towards. If your eye, or say the coin, was looking back at you, it's going to go through the water, which is the transparent, or the glass, which is the transparent, and it's going to bend away from normal. Okay, so look at these angles. Are they the same? No. This is definitely going away at a farther degree, and this is going towards normal at a smaller degree. So make sure you label air and water. 12.5, spectrum of white light. So you can split light, and white light can be split into the spectrum of colors called dispersion, which the tool is a pretty, it looks like a glass triangle, and it's called a prism. And when you put light through it, it creates the rainbow. And the way you can remember the rainbow is Roy G. Biv. And some of you may have already learned this to memorize it by Roy G. Biv, but that's the easiest way. Red, orange, yellow, green, blue, indigo, violet. Dispersion is caused by refraction. So I went ahead and drew you a picture. Here's white light going into that glass triangle called a prism. It's being refracted, and then it creates the rainbow. I would draw this just like this so you remember how the rainbow is created. White light enters, the rainbow exits. Now, there is a such thing as colored light. And we have primary and secondary. These are very similar to art, but then they're going to be a little different on the next section. So you got to remember, these are colored lights. So primary is red, orange, and yellow. Secondary is, I put orange twice. That's my mistake. It should not be orange, but I will figure that out and let you know. All right, so it should be red, orange, yellow. Oh, this should be red, blue, and yellow, and then this should be orange, green, and purple. So blue should be over here. I apologize. So that's a mistake on my part. So red, yellow, and blue, orange, green, and purple. I apologize for the mistake. All right, so we have a filter, and this would almost look like, like at Christmas, you get those like little cute Christmas breads or cookies, and they have that colorful, clear wrapping. But sometimes they're like red or green because it's the Christmas time, or sometimes they do blue and silver. So there's this colored plastic, okay, and that's like what the red filter would look like. It only lets through some of the colors made up of white light. So if I put a red piece of that Christmas cellophane and I put white light through it, okay, it actually absorbs that white light, and that red filter absorbs all the rest of the colors, and the only color that shines through it is red. And so keep in mind, white light's made up of all the colors. So if only red's coming through the filter, that means that filter's collecting all of these colors. Now, how do we calculate colors? And you're probably thinking, oh my goodness, what is she talking about? So, it's super easy, but you need to draw my diagram. Maybe find a nice little circle, because I obviously did not, but find a little circle and you need to make it look just like mine. And you need to label it just like mine. If you don't, it will be really confusing. All right, now, when we're talking about actual, like, adding and subtracting colors, our primary colors are red, green, blue, and our secondary colors are cyan, magenta, and yellow. And so here's how easy it is, okay? I'm going to show you. If you take green plus blue, you make cyan. If you take plus green plus red, you make yellow. If you make red plus blue, you make magenta. That's how you add. Now, how do you subtract? So if you take white light minus magenta, you would get green because that's what's left over. Okay, because red and blue are gone, so the only thing left over is green. If you take white light minus cyan, you're taking away green and blue, so you're left over with red. If you take white light minus yellow, you take away these two because that's what makes yellow, you're left over with blue. And then if you add them all together, red, green, and blue, you make white light. So make sure you kind of understand that. Now, if I just took away, say if I did white light minus blue, you would get left over with yellow because yellow makes up red and green. So just kind of keep that in mind. Use that diagram to help you. It is kind of tricky, so if you need help, I'm more than welcome to help you. But if you kind of look at it and I can't really do it. I'm actually holding my thumb up to the computer screen. But you know, like when I made you all do our triangles with the speed unit and we would cover up, or your force of motion unit, and we'd cover up whatever we're solving for. I want you to cover up whatever you're solving for, and then you'll see what's left over. If it's two colors left over, you'll do the blended color. If it's only one left over, that is the answer. And so if you need help, I know this is a really hard part to kind of understand, but your gizmo goes over it. So if you're struggling, even if you don't want to do the gizmo as your second week, if you want to get onto the gizmo and just play around with it, it does help you solve these. So if you need help on your unit packet. So once again, I apologize for the correction here. This should be red, yellow, and blue on 12.6. But other than that, I feel like you will really understand this topic, and I think that you'll really enjoy your do-it-yourself projects. So even if you don't have all the things, try to just look at them and see if you might around the house, or if you need substitutes, message your teacher, and maybe we can figure out something you can use around the house instead of something else. But we certainly miss you all, and please try to join the Zoom meeting on Tuesday, April 21st at 1 p.m. Miss Johnson's niece is a scientist and just graduated with her doctorate, and she would love to share more information about what she's up to. So I look forward to seeing you all on Zoom, and I miss you all so much. Thank you.